So CIS40A, in this video, I'm going to talk about Unit 3 content and also Unit 3 assignment. In this chapter, we are going to touch on network components from adapter to appliances. So in the first part of our notes, it contains information about the network interface card. It is also known as a network card or network adapter. This can be an adapter that would be installed onto a bus on a motherboard, or it could also be a USB, and it could also be wireless or wired. Now the network interface card, it would then be used to transmit signal through your media, which is your cable, and that will be electrical signal. It would prepare the data before it transmits. And then when it receives the data on the receiving end, it would convert the electrical signal and to be able to format the data and present the data to the system. So some adapter are integrated onto the motherboard. It's also known as onboard or built onto the motherboard, as you see in the picture here. And then other type of adapter would be an external adapter that would be installed onto a slot on the motherboard. And the picture on the right shows the Ethernet adapter. This would use Ethernet cable as a medium to connect that system to the network. Now, some server would utilize network adapter or multiple network adapters, sometime either built onto the motherboard or externally installed. So then for that, you would see that it would be integrated to the use of that server, because we might need to be able to send and receive on specific adapter or what we call interface. And with the network interface card, we would see transceiver. And transceiver simply is a portion of the network interface that would send and receive signal across the cable. So it's used to connect to the cable. And it would pick up the signal and verify if the data is destined for the system. If it's not, then it would just discard it or dispose of it. There are two types of transceivers. That's going to be onboard or external. Onboard just simply means that it's built onto the actual adapter for the network interface card, or it would be external, where it would be a separate component that we would attach to the back of the system. So the onboard transceiver, it would look something like this, and in this case you would see that it is a coaxial. So it's built directly onto the motherboard, as the picture is shown with the arrow pointing to it. The external transceiver, you might see it like an attachment like this, and the benefit of the external transceiver is that you can attach this to different type of appliances where it doesn't have to be directly attached, included with the network interface card. Some of the older system, it would use a unit called attachment unit interface, AUI connector, and this you can purchase separately, and you would be able to connect to the interface. In the newer network, you would see something on the right hand side that would be your SFP, and SFP module contain transceiver that you would select based on the need of your system. On the left, you would see some older attachment unit interface, and it uses different type of cable connection there. Now, the more modern transceiver that you see today, you would see such as GBIC or SFP. And this would use on switches and routers, so that way you can connect your cable to those devices. And you would use the appropriate cable, of course, to interface. So for the SPF port, that would allow the transceiver to be connected, and then depending on the type of cable, so in the case of we're using Ethernet, then that will be 1000 base T copper, or sometimes that will be fiber. So fiber optic or copper cabling is what we currently use in our current network. So SPF is small form factor pluggable transceiver. It allows you to connect to different type of interfaces, meaning that we can connect different cable to that particular transceiver. SPF Plus is enhanced for small factor pluggable or hot swappable replacement of SPF. So it's just an enhanced level with a throughput or transmission rate that's a little higher. Your QSFP, that's going to be quad small form factor pluggable, and that would allow you to connect and transfer 4 times the enhanced version, and that supports 4 times 28 gigabit per second. So the QSFP is quad, so it's going to be 4 times compared to SFP or SFP plus. GBIC is known as the Gigabit Interface Converter. This is used in gigabit network. It supports the transfer rate up to 1.2 gigabit per second. It is hot swappable technology. So when we say hot swappable, that means that the system can be on or the device can be on where we would be able to detach it and install another one. Where in some case, if it's not hot swappable, that just means that you have to shut down the system and then you can uninstall that component, and then you would have to replace that component with another component before you restart the system. So here lists the modern transceiver types. Now, next I'm going to go to the assignment to answer some of the questions. In the first questions, it asks you to describe the functionality of the network interface card. It is responsible for preparing data from the system that needs to be transmitted, and it verifies if the data is intended for that system or going into another system. So as it receives the data, then it converts the electrical signal and prepare the data for that particular system. You can find this information on page 1 of your notes. For number 2, it asks you to describe the difference between onboard and external transceiver. Onboard transceivers are built onto the network interface card, and that allows you to connect to the media connector in the back of the network interface card. External transceiver is a media connection that's made with external component that allows you to connect to your device like routers and switch. The benefit of the external transceiver is that you can buy different attachment and connect to the switch, so you can use different type of cable and you would have different port to interface for your network. So there's some flexibility if you're using external transceiver compared to onboard transceiver, where if you have onboard transceiver, then you would need to replace the adapter accordingly. Number 3, it goes into troubleshooting your network interface card that uses different or multiple types of connector. What would you do? So if we're using different type of connectors, we want to enable the auto option, so that way when the connector is plugged in, it will be able to detect what kind of connector it is, so it would adapt accordingly. If we set it for a specific type of adapter, then we have to manually configure it. Otherwise, it would not be able to detect the interface. Going back to the notes, after it talks about transceiver and show you the picture of different type of transceiver there, it talks about transceiver configuration and network interface card troubleshooting. So we talked about the auto option or the auto setting for the transceiver that uses different type. And so we want to change it to non-auto, or it's not able to configure the auto, then you would go to the network adapter properties, which it can be found in either device manager in Windows, or you can go into settings and click on network and internet, and you will find the adapter and click on it. Then you can force it to be a specific speed, so you have to manually specify it that way if you don't set it on auto. So how does the network interface card transmit signal? First, it can do a simplex, which is only one direction. So the system can only send or receive on the simplex, not both. Half duplex is going to be both directions, send and receive, but not at the same time, meaning that it's going to receive and then send, or send and then receive. It cannot be concurrent. Full duplex means both communications are happening at the same time, where the system would then be able to send and receive data simultaneously. Make sure that you know simplex, half duplex, and full duplex for our quiz and exam, along with the CompTIA Network Plus exam. Then it's going to go into MAC address. So MAC address, MAC stands for Media Access Control Address. This is used to identify the system, and MAC address is 48-bit, so that means that it uses hexadecimal, and that would give us 12 characters of hexadecimal format. The first half, the first 6 digit of your MAC address is used to identify the manufacturer ID. The second half of the address, which is the other 6 characters, because there are 12 characters or digits in the address, that will be significant to the unique ID of that system. So as you can see in the picture here, the 3 bytes, that's going to give you the 6 characters in hexadecimal. That will be for organizational unique identifier. So the manufacturer, they're given a set of a block of MAC address to utilize, and so that's how we manage the MAC address, so there's no overlapping. Now, some manufacturer, as you see in the first lab, they would purchase or buy the adapter from elsewhere, but they would still, and so that MAC address, the OUI, is registered as another company, where it would not be the company that's selling your system. So here it shows that when you see the bits here, that can either be unicast or multicast. If it's 0, that's going to be unicast, and 1, that will be multicast. And multicast just means that it's able to send to multiple systems. Okay. Now for the OUI 0, that allows us to identify the globally unique, and 1 is going to be locally administered. How you can find which company has which OUI, then you can use a database tool to check, such as Wireshark or IP Check or MAC Address Check app, as we've done in the first lab of this week. So in the questions for your assignment, for number 4, we're going to go back to the type of methods that used for the NIC to transmit data. Which method provides the highest throughput? We would say simplex, allow communication in one direction, receive or send, cannot be both. Half duplex, it's able to send both direction, but it has to send after it receives, or vice versa. So when the adapter is set to half duplex, it will not be able to send and receive simultaneously. For the full duplex, it allows the communication in both directions at the same time, and so we will be able to send and receive concurrently or simultaneously. So full duplex provides the highest throughput rate, and you want your adapter to be set at full duplex if you want high throughput. Now, in the case where we don't want to send and receive simultaneously, then we can put it to half duplex, or if we want only to send or receive, then we can put it down to simplex. For question 5, it asks you, how can you determine which manufacturer produced the network interface card that is installed in your computer? You would locate the MAC address and use the first 6 digits or the first 3 bytes of the MAC address and use those characters in a tool to look up the OUI on the web. And this will tell you who manufactured that particular network adapter, and it is registered. Now, in the next part, we're going to talk about troubleshooting Nick. And so in question 6, it asks you, how do you troubleshoot a network interface card? So as I recommended in your lab today, we want to look at first cable connection to the Ethernet card. So we want to check to see if the cable is securely connected. If it is, we're going to try to see if there is faulty cable or bad cable. Then we are going to look at the LED or the link light to verify that there's physical connection. If there is, you would see green light in general for most adapter. And if there isn't connection, you would see an amber or yellow light. Once we verify that there is link light, then the next step would be to check the network interface card configuration for IP address, whether you're using IP version 4 or version 6. Once we have the information for the IP address, we would see how it would be responding if we start using ping. Ping is a way to see if the system will be able to respond by sending signal to that particular system. So we can ping the IP address, or we can use a loopback address such as 127.0.0.1. And if there are replies, that means that that system would be connected. If all the packets are lost and there's no reply, then that means that there is additional issue or we have to continue to troubleshoot. We can also run Diagnostic System. Windows has diagnostic tool that's built in, and you can find this in either Control Panel under Network and Sharing Center, or if you open up Network and Internet in Settings, and if you click on a certain interface like Ethernet and Wi-Fi and the network that is shown, it would give you a link on how you can troubleshoot it. So in general, we would simply check cable, check light, check IP configuration, ping it, or we can use diagnostic tool. So now returning to the notes, on page 4, we would find the network interface card troubleshooting steps and how we can test it. So we can test it using the cable that's connected. We wanted to see if there's activity in the light and see if it's sending. We can ping the system. We can also use diagnostic tool and loopback test. So that way it would be able to send loopback requests back to that system. So basically it checked to see if the system sees itself connecting, and the data would then be sent out of the card and then come back to that system. So that way it can check to see if it's connected. We should also look at drivers for the network interface card. So driver is simply a software that enables the operating system to communicate with the hardware. And if the driver is outdated, sometime you might run into issues. Or if there's corrupted or bad drivers, that also does not allow your hardware device to be able to communicate or operate as it should. So a way that we can update driver is we would access its property, and we would be able to see an option to update driver in Windows system. Windows update sometime would also include additional updates for the software. And so we want to update it if it is not communicating accordingly or operating as we expect. And sometimes if you update and it stopped working, then you can roll back to the prior version. So that might be also an option. So in the questions, question 7, it asks you how to update a network interface card driver in Windows 10. We want to open up Device Manager, and you can do it by right-clicking your Windows button. And then you can go to Device Manager here, or you can go to Computer Management and choose Device Manager, or you can simply type in Device Manager like this. Now, once we're in the Device Manager, we would then be able to find the network adapters and then expand, and we would be able to right-click the network interface card and check for updates. So if I'm in Device Manager, as I show you here, I'm going to go down to Network Adapters, and let's say that I wanted to right-click this, and I would choose Update Driver. We can uninstall the device, we can disable the device if we no longer need it, and then we can also scan for hardware changes. But if we need to access this property, it is also here. You can also access driver updates by clicking the Driver tab. We can roll back the driver to the prior version, and we can also update driver. Like some of these options show up when you right-click the actual adapter. Next, we are going to talk about hubs and also switches. So hubs and repeaters are older technology. Hub was used to connect multiple systems. It is a concentrator. Basically, it's responsible for the systems to centralize connection. And when a computer sends data to another computer, it would then transmit signal from the network interface card to the hub. And the hub would take that signal, and then it's going to send it to each of the system to check to see if the data is destined for them. So compared to what we see with the switch today, hub is less efficient. However, it was a way that we would connect the system back then. And you might still see networks that use it, but hubs are not efficient in the network, so eventually they will replace with switch. Now, if it would send data to all ports, so it would then broadcast it, and that becomes a security concern. Because what if it's not intended for other system, and someone can easily sniff out or look at or analyze the traffic from the actual hub. So here you should see some pictures that would show you different types of hub. Now, similar to other network appliances, it would show the link lights when the system is connected with the cable. Some hubs can also be wireless back then. If you have collision on the hub, then you would then need to be able to monitor it, because otherwise you will likely experience collision with the hub, and it would be excessive in some case that would slow down or even take down your network. In the next section, it talks about how we would do hubs cascading. Basically, that is, we would connect a hub to other hubs to multiple hubs and so on. So when you're trying to connect, if you try to chain two hubs together, then it would likely that you can connect multiple computers to that hub. Now, when you do a hub to a hub, you would then need to use a crossover cable. And crossover cable, different than your regular Ethernet straight through cable, as we talked about this in week 1, that it would have different cross signal on the wire. So you would use different standard in when you're creating this cable for the connector. You would wire it up differently. And so when we're connecting same type of device like a hub to a hub, then we would use a crossover cable. When we're connecting the computer to a hub, we would use a straight through cable. Now, if you want to connect 3 hubs together, you would need to have an uplink port from the first hub to any of the second hub. So you would connect port 24 to the first, and then use the port 24 from the second to the first again. So what you do is you would subsequently going from one to the first port to the last port, and from the last port to the next hub first port. And that's how you're able to chain it together, to chain them together. So for number 8, it asks you, how do you connect 3 hubs that consist of 3 ports? You would connect the uplink port on the port 8 on the first hub to any port on the second hub, and then use the port 8 on the second hub to the uplink of the first port on the third hub. So you would go from the last port on the second hub, going into the first port on the third hub. Now, there are 2 types of hub, active and passive hubs. And the passive hub contains no power source or electrical components. And there's no signal processing. There's no regenerating of signal. And just that is readable for a certain destination. An active hub has a power source, and it also have a repeater, so it will be able to repeat signal, increase or amplify signal. So as you can see there, that will be the main difference between those hubs. So after hub cascading, you would see a picture of that there, and it goes into passive and active hubs. So an example of a passive hub would be that the 8-port hubs receive the data from port 3, then send the data to port 1, 2, 4, 5, 6, 7, and 8. It has no power source. It's simply attached to the ports internally, and it allows a communication to the network. Where the active hub, same as a passive hub, in that it would amplify the signal or regenerate the signal, so the signal can go further in the distance, and it would allow the data to be able to reach a certain destination. The maximum is for UTP, which is your unshielded twisted pair, your Ethernet cable, that will be 100 meters, as the cable is limited to 100 meters. So active hub is also known as the multi-port repeater. It can repeat, boost, amplify the signal. Next, we're going to talk about repeaters. You can use repeater to enable signal to go farther in distance. you would place the repeater where the network right before it would be able to reach maximum distance. So the repeater would take that signal and regenerate it so that signal can go further. The next few appliances we're going to talk about bridges and switches. A bridge is network connectivity of the device that's used to break down a network into multiple networks. A bridge runs at layer 2, which is your data link layer, and we can use it to filter traffic by forwarding. And so when the signal reached the bridge would look at the MAC address as it is a layer 2. And so the bridging, it would put that MAC address into a table, and that table would be used to refer to which MAC address for which system. And so this table is important for filtering. Now, over time, the table would be filled for a group of systems in that network segment. So the best device that you can use internally in your network to connect multiple systems would be a switch instead of the repeater, the hub, or the bridge. Now, when we connect two switches together, we would call that a bridge of switches, meaning that we can either mirror or filter using one of those switch. So switches give you more security and more reliability in transmission of data. So in the standard hub, the bandwidth would be limited and security would be limited. Compare that to a switch, even though it's operating at layer 2 like bridges. It used frame to frame the data, and then that would allow the system to construct what we know as packets that will be used for routing. VLANs is known as Virtual Local Area Networks. This is incorporated in almost all switches today. The port we can configure for VLAN, so that way we can isolate certain group of systems that are connecting to specific port, or we can set up a certain type of service for those type of system. And it would use an identification number or an ID. So a way that we would be able to specify which group of system would belong to a certain VLAN is by its ID. So the purpose of VLAN is really to reduce broadcast traffic, and also we can isolate a certain part of the network so that way it doesn't intervene with other part of the network by specifying the port that we want to group them together. Now, broadcast just means that it's sent to all systems. So with the VLAN supported switch, you can create VLANs as broadcast domain. And so that just means that when a computer on the VLAN 1 is made up of a certain group of ports like 1 through 12, and for that system to send traffic to all the system, it would only send to the other 11 port that is connected to the first port. Now, the benefit of that is you can minimize specific traffic that would travel across the switch, and then you would have a higher throughput overall. You can also use it to separate certain traffic for monitoring, security purposes. So to create VLAN, you simply just use the utility that comes with the switch and be able to enable or identify the physical port to a certain VLAN ID. Then we also want to group up the IP addresses accordingly as a subnet. So that will be the next layer up. So it can then transfer data only to those, or broadcast data only to those systems that are grouped. you would have different type of switches, the managed switch and an unmanaged switch. A managed switch allows you capability to configure the features. So some of the features you might see would be spanning tree protocol, your STP. This is layer 2. It's designed to prevent loop. Or another feature would be trunking, in which you would connect the switches together and then assign the ports as a trunk. Trunk is used to carry VLAN traffic to another switch. So it's a way that we set up a path from one switch to another. And VLANs are allowed to contain ports that can be carried across multiple switches as members. We can also make sure that data is destined for a certain system, like how we talked about podcast earlier. Another feature would be ISL or 802.1Q. This is a way that we can assign VLAN identification to the packet. It is known as tagging. So ISL stands for Inter-Switch Link. This is a protocol that's used in tagging. Now, the 802.1Q is another protocol. It is used for trunking. So ISL is used to tag packets that is associated with a certain VLAN, where 802.1 is the protocol that's standardized for VLAN trunking. And so most switches today use 802.1Q as a tagging method. So for Cisco proprietary, you might see ISL, but in general for other brands, like what we've seen in the lab today for 3-2 lab, you would see 802.1Q. Port monitoring. Port monitoring is a feature that allows the switch to send a copy of the data that reaches a certain port, and it allows the administrator to use that port to copy the data from one port to another for monitored traffic in the case of attacks or suspicions for a certain type of traffic. It is important, so you can set it up through the configuration of the switch, and we would then specify the ports in the configuration interface. We would use it to monitor, we would use it to defend attacks. Another feature would be your port security. This allows the administrator to identify the MAC address and how that would be connecting to a certain port. So we would tie the address to a specific port. Lastly, for one of the features would be authentication. Port authentication help us increase security. As the system is connected to it, it would then it will be required for authentication. So in our assignment, we can go further and we can answer the next few questions. For number 10, on a network, what is the purpose of a repeater and where should it be placed? The repeater is it's used to rebuild the signal so that way it can go in farther distance. It should be placed before the maximum distance of the cable or the signal range, so that way it can expand the signal range to reach other systems. Then in question 11, it asks you what type of addresses is used by the bridge to determine the network segment of the destination, and how does it use this address to filter system connection. The bridge is going to use the MAC address, and it's used to determine what part of the network or which network segment is the system in. This address is then stored into a table, which is the memory or the RAM of the actual bridge or the device. then it will be able to narrow down or filter the location of the actual system based on what's stored in the table. For question 12, it asks you, why should we use switch to connect system devices instead of a hub? Switch is going to give you higher security. And so in the case where the transmission is not complete, it won't be, it would then try to regenerate. Also, it doesn't send it to every port, and so it's only going to be for the destined system. The bandwidth for the standard hub is then shared because it's then sent it across the user. So it would also take up full network bandwidth in order to do that. So you will actually have higher traffic using the hub compared to the switch. For question 13, it asks you to explain the benefit of Virtual Local Area Network, or VLAN. This is used to minimize traffic across the switches, which increases network throughput. It also allows us to separate different types of traffic from the switch. We can isolate a group of systems for different purposes in our business. For question 14, it asks you to describe the purpose and the benefits of the protocols and feature. Spanning tree protocol, which is STP, it is used to prevent loops in the network. And so this protocol would look at all the ports and create a loop and then place it into those ports for blocking state of the data with no traffic can pass through that port. So when the port is blocked, that means that only other links, if other links go down, the port is then transitioned to a forwarding state. So it will then activate to forward and allow the data to be sent received on that particular port. So STP is a good feature to include if you want to prevent loops. On trunking, this allows you to connect the switches together. So we would assign one port as a trunk port, and that port would then be connecting to other switches. We can trunk the port that's used for VLAN traffic to another switch, and VLAN would then be allowed to contain the ports from the multiple switches as members. So we would specify a certain physical connection for trunking purposes. ISL and 802.1q, we talked about inter-switch link, which belongs to Cisco. It's used for tagging packets and associating them to a certain VLAN ID. This is used in the older switch. The newer one would use 802.1q. This is used for trunking and tagging. So most switches today would use 802.1. Port mirroring allows the port to send copy of data that reaches a certain port to the mirrored. So in the lab, you saw that we mirrored 3 and 5. So basically, it copies the data from one port to another port. For port security, this allows the administrator to affiliate the MAC address of the system to a certain port. So if other systems were trying to connect to that port, it would not allow. And port authentication can help you increase the security of the network. It also allows only a certain type of system would be connecting to that particular appliance or that particular connection. This concludes the first part of my video. I will follow with the subsequent video where we will talk about other appliances such as router.